Okay, so let's look at a practical example of this now. So we're at the point where we have the server booted, but the server doesn't yet have any network configuration. So if we look at the default splash screen of ESXi, VMware ESXi, once we run the installer, it's going to be running DHCP on the management interface, or what we call the VM kernel. Okay, VM kernel is basically management port of VMware. Okay, so from the splash screen, you hit F2, and then it should ask us to log in. Okay, the username is going to be root, and then the password should be CCIE-DC01 with a capital C. So capital C, lowercase CIE-DC01. Okay, if it just returns back to the splash screen, it means it works. Then you hit F2 again to go to customize, and we're going to go to configure the management network. Okay, under the management network, let's go to network adapters. So here we can see that there's two network cards. From VMware's naming point of view, they call them VMNICs, for VMware NICs. So it sees VMNIC 0, VMNIC 1, and then we have two MAC addresses here that are 9F and 8F. These should be mapping to our VNICs, or our virtual NICs, that we had configured under the service profile. Okay, so let's go back to the UCS Manager and let's look at the virtual NIC cards and see what MAC addresses that they have assigned. Okay, the reason that I want to check this is that we need to make sure from an operational point of view that when the Fabric Interconnect is creating these virtual Ethernet interfaces, okay, so it's going to be creating virtual Ethernet, whatever, 1, 2, 3, 4 on Fabric A, and it's going to be creating virtual Ethernet number, let's say VETH 1, 2, 3, 5. Normally they're going to be sequential, and then these get assigned down to the blade. Okay, so in our case, this is blade number 4. And from blade number 4's point of view, the OS is going to see these as different physical adapters. Okay, specifically, VMware is seeing these as VMNIC 0 and VMNIC 1. But the key that I need to make sure of is that VMNIC 0, I want this to map to VNIC 0 from a configuration point of view. And then likewise, VMNIC 1, I want this to map to VNIC 1 on the UCS side. So this is just going to be from a troubleshooting point of view that if it's 3 o'clock in the morning, you're trying to troubleshoot connectivity problem to the server, if 0 maps to 1 and 1 maps to 0, it's just going to make it overly confusing to figure out what is the actual traffic flow. And the key here is that when the server goes to boot up, you don't always place the network cards in the order that they're numbered. So you would assume that VNIC 0 comes first, but it's not always the case. That's going to be controlled by what we call the PCIe placement policy. So the VNIC VHBA placement policy, it would basically be the same as that if you physically open up your desktop or your server and then pulled out the network card and moved it to another PCI slot, it means the CPU is addressing it as a different network adapter. Okay, just like in Windows, you would see local area connection 1, local area connection 2. The numbering convention is based on what the BIOS sees the PCI card as. But from our point of view, this is going to be logical because we're logically programming the VIC card with these different network adapters. So we have control over where they're going to be logically placed on the bus. Okay, the first way to check whether this actually happened correctly is to map the MAC address that we see on the OS. So the OS in this case is ESXi. We're going to look at the MAC address of the VMNICs and make sure that these map to the MAC addresses of the VNICs. If they don't, I'm going to have to change the placement policy and then reboot the blade for it to actually take that effect. Okay, so we saw from the KVM console the first network port, so VMNIC 0, it ends in the MAC address 9F as in Frank. Okay, so on the UCS Manager, we're going to go back to servers. Then we're going to go to the profiles called Brian Profile 2. We're going to go under VNICs, then VNIC ETH 0, and look at what MAC address is assigned to it. Okay, so ETH 0 is assigned MAC address 8F as in Frank. VNIC ETH 1 is assigned 9F. So 8F should come first, 9F should come after that. And if we look at this from a VMware point of view, we see that it's opposite. Okay, 9F was first and 8F was afterwards. This means that VMNIC 0 is mapping to VNIC 1 and VMNIC 1 is mapping to VNIC 0. So the first one is actually on the B fabric, the second one is on the A fabric. From a troubleshooting point of view, it doesn't make sense to leave it like that. Okay, so before actually configuring IP, we're going to make one other change, which is to reprovision the NICs, and then we're going to have to reassociate the blade, or basically reboot it in order to get this to apply. Okay, so specifically where we're going is going to be under servers, under the service profile, under general, and then we're going to modify the VNIC VHBA placement policy, okay, right here. Now, I did have the option to do this under the service profile wizard when I was creating it. So we'll see in later examples when we're actually creating more service profiles and we're creating a template. We're going to create a template that has this placement policy manually defined so we don't run into this problem again. Okay, and notice right now it says let the system perform the placement. And in our case, the system is placing it wrong, where we want this to be 1, 2, 3, 4. Right now it's something like 1, 2, 4, 3. Okay, so we're going to specify this manually. Okay, we're going to take the first VHBA and apply this as the first adapter on the bus. So HBA goes first, that's going to be order number 1. The next HBA is going to go next. The first NIC is going to go third, and the fourth NIC is going to go fourth. Okay, so FC0, FC1, ETH0, ETH1. Think of these as different physical PCIe slots on the motherboard of the actual server. But the difference is that in our point of view, it's a logical configuration as opposed to a physical change. But notice here it says this will trigger PCIe reprovisioning of the VNICs and VHBAs. As a result, the placement will change across the host reboots, and this is going to cause the server to reboot. Okay, do you want to do this? Yes or no? Yeah, I want to reboot the server. So you'll see in a lot of cases with the UCS, if you don't manually define all of the options that you want to begin with, when you go to change those later, a lot of them require you to turn off the server, flash the changes onto the chipset, okay, like the VIC card in this particular case, and then reboot up the OS. So it is a disruptive change. Okay, it's basically like powering off the server, opening it up, moving the cards around, and then rack mounting it again, plugging it in, and powering it up. Okay, so if we go back to the KVM console, we should see that the server is going to reboot here shortly. Okay, if we look at overall status, it says config. It means that it's making a change on the service profile, or it's making a change on the physical server. Okay, so while we're waiting for this, let's go to the Nexus side and let's set up our regular LAN connectivity. So if we go to 5K1 and 5K2, okay, so I want the console of the fabric interconnects, and then I want to telnet to 5K1 and 5K2. Okay, you can also telnet to the fabric interconnects, but they're not listening for telnet by default. If you wanted to enable telnet, you can do this from the CLI or you can do it from the GUI. From the CLI, you would say, I want to scope to, I want to say that this is going to be scope to system, and then scope to services, and then enable, and I'm hitting a question mark here, enable telnet server. Okay, then after every time you make a change in the CLI, you need to say commit. Okay, that asterisk means that you need to save the changes. Okay, so again, from the CLI, this was scope system, scope services, enable telnet, commit. So you see here that the UCS CLI, so not the Nexus CLI, the regular UCS scope syntax is completely different than regular iOS, XE, XR, NXOS. So it's a separate CLI that if you wanted to make changes from the CLI, you'd have to learn that separately. In my particular case, I don't really use the CLI for making changes. I only use the CLI for verifications. Any of the changes that I make would be from the GUI or from the scripting calls if you're doing something larger scale, like the APIs that the UCS manager has. But technically, everything that we've done up to this point, you can do it from the CLI under the scope syntax. And there is a reference for this in the configuration guides, what the syntax is going to be. Okay, but what this should mean is that I should now be able to telnet into the fabric interconnect. So in this case, I'm telnetting to the virtual IP address. So my login is admin. And then this should drop me off on whatever Fabric Interconnect is currently primary. If we look at the show cluster state, it says A is primary, B is subordinate. Okay, so telnetting to the 192.168.0.100 is landing me at Fabric A. Okay, next we're going to say connect NXOS. Then show interface brief. And what we're looking for here is going to be the virtual Ethernets and the virtual fiber channel ports. Okay, so we have virtual Ethernet 702, 8892, 8896, and we have virtual fiber channel 700 and 704. These are going to be corresponding to different VNICs and VHBAs of the service profiles that are currently associated, or in other words, of the physical servers. Okay, so this is going to be our next step in connectivity, is that we need to know which VETHs, which virtual Ethernet interfaces are actually mapping to server chassis 1, slot number 4, where I have the service profile applied. Now, there's a couple different ways you can figure this out. If you're on the CLI, you can simply look at the show interface, like show interface VETH 702. And this says that this is server chassis 1, slot 4, virtual NIC ETH0. Okay, so this is going to be the A fabric adapter for our particular blade. The other way to check this from the GUI would be to go to the physical server. So we're going to go under equipment. Then under equipment, we're going to chassis. Under chassis, we go to servers, server 4. Okay, so the physical blade where the profile is actually associated. And then under the server, we go to the VIF paths, the virtual interface paths. Okay, what this is going to show us when we open these up is what are the virtual Ethernet and virtual fiber channel numbers, and how do these correspond to the physical uplinks. Okay, so it says that we have virtual circuit 702 that on Fabric A is ETH0, the VNIC named ETH0, and then what uplink is it using? Right now it says it's unpinned. And we'll talk about this in a second here, what the pinning decision means. But what this is showing us is that, for example, the storage adapter, which is virtual fiber channel 704, is mapped to the virtual NIC FC0, which is actually a virtual HBA, but it's still Ethernet because it's fiber channel over Ethernet. So it's mapped to VHBA FC0, which is using the physical interface 1/31 on the Fabric Interconnect to leave, or in other words, it's using FC 1/31. Okay, from the CLI, there's going to be two commands that we look at in order to verify this. For the storage connectivity, this is going to be the show NPV external interface usage. Okay, this shows the mapping from the downstream storage port going to the server to the northbound physical link that's going up to the physical switches. So in this case, virtual fiber channel number 700 is mapped to physical fiber channel 1/32, whereas virtual interface 704 is mapped to physical interface 1/32. So it's kind of doing a load balancing between the two of them. It's not on a per packet or per flow, but it's on a per adapter basis. Okay, so this is going to be the storage pinning. For the LAN pinning, the regular Ethernet VNICs, we can say show pinning, and then we could say show pinning for the actual interface, like VETH 705. Okay, or this actually was, let me go back to the GUI, this was 704. So let's say show pinning VETH 704. Okay, that's actually not a VETH, that's a VFC. So let's say show interface brief pipe to include capital VETH. And we have 698 and 702. So let's say show pinning interface VETH 698. It says that this is leaving out port 1/3. Okay, if we show pinning for virtual Ethernet number 702, this is likewise leaving out E1/3, which I think is the only uplink that I have currently configured. But basically what this shows us is what is the switching decision that the system is going to use as traffic goes from southbound to northbound. Because remember that the key difference with end host mode for Ethernet is that you do not learn MAC addresses northbound. You do learn MAC addresses southbound from the FI down to the blades, but in order to reach the rest of the LAN, you have to make some sort of decision, and in this case, since we're not doing it based on destination MAC address, we're doing it based on this binding of the source interface, the server interface, bound to the border interface. So basically what this means is that if we show interface for VETH 698, it says this is bound to chassis number 1, slot number 5. Okay, so blade number 5. This means that when traffic comes from blade 5 and it's exiting on VNIC ETH0, this really behind the scenes from the fabric interconnect point of view is virtual Ethernet number 698, and virtual Ethernet 698 is physically bound to Ethernet 1/3. So it means that when the traffic leaves that's going up to 5K1, it's going to be leaving on Ethernet 1/3. Okay, so we're doing a static switching decision or a static pinning decision to move the traffic from southbound to northbound.